This is a second way of graphing transformations of sine and cosine. This way, instead of transforming graphically, is more based on your table. So I'm going to first draw the parent function table. At 0 degrees or 0 radians, you can either look at the unit circle or you can look at your parent function graph to see what the cosine is. That's going to be 1, your x value, or from the graph we see it's at 1. Then pi over 2, the x value is 0, or you can look over here, we're at 0. Pi is -1, 3 pi over 2 is 0, and 2 pi is 1. Then we need to see how the graph transforms. The 2 is like a vertical stretch, because that's the amplitude. So that's gonna change your y values. It's gonna be 2y. And the +1, remember transformations outside the function, either whether it's multiplying or adding and subtracting, are affecting your y values. So that's gonna be +1. There's no phase shift, but we see 1/2 x. So that's gonna end up actually horizontally stretching your graph. Remember, inside is always opposite. Whether you're stretching or shrinking or shifting, it's always the opposite of what you might normally think. So that's gonna be a 2 times x. And we can apply those transformations from the old table. 2 times 0 is 0. 2 times pi over 2. 2 times pi over 2. The 2's are going to cancel. So we're going to be left with pi. 2 times pi is 2 pi. 2 times 3 pi over 2. That's going to be 6 pi over 2, which is 3 pi. And 2 pi times 2 is 4 pi. Now we're going to do 2y plus 1. 2 times 1 plus 1. That's 2 times 1 is 2 plus 1 is 3. 2 times 0 is 0 plus 1 is 1. 2 times -1 is -2 plus 1 is -1. 2 times 0 is 0 plus 1 is 1. And 2 times 1 is 2 plus 1 is 3. And we can plot those points now. So 0, 3, pi 1, 2 pi -1. And I need to keep labeling my axis. This is 3 pi and this is 4 pi. 3 pi is at 1 and 4 pi is at 3. And then we can connect our points. And we know the domain is -infinity to infinity, so I'm going to extend it in both directions. So when you do this method, you just need to make sure that you're good with adding and subtracting and multiplying fractions, because that's going to be the biggest challenge here.